we have finally moved on to Module 5. And because I forgot to hit record before, I'm going to go a little quickly through the introduction. So the students in class, I apologize, but you're going to hear this again. It's a good review. Module 5, we're focusing on area, surface area, and volume problems. We've been reviewing this all year, so a lot of it should seem very familiar, and you've done this in elementary school, so this should be very familiar. The first section of Module 5, which is Topic A, will be on triangles, quadrilaterals, and polygons. I think you all know what a triangle is. A quadrilateral is any four-sided figure, and a polygon is any figure with three or more sides, all straight sides, and closed figure. Ladies, I'm going to ask you to put all that away and stay with me. Today, for Lesson 1, we're going to focus on the area of parallelograms through what we know about rectangles. So let's start by reviewing our basic shapes: the rectangle, parallelogram, acute triangle, rectangle, and trapezoid. We already discussed the difference between a parallelogram and rectangle is that a rectangle has to have 4 right angles. Both rectangles and parallelograms have 2 sets of parallel and congruent sides, where the trapezoid only has 1 set of parallel sides. All of the figures on the board are polygons because they have 3 or more straight sides in their closed figures. Okay? So now let's take a look at this. It's not in your notes. We're going to discuss it first, and then we'll try some. Well, how do we find the area of a rectangle? This you know. I know you know this. How do we do it? Length times width. So here's your length. Here's your width. Does anybody know another name? Instead of saying length times width, what's another way they might say that? Base times height. So here's your base, and here's your height. All right. Now we know that's a rectangle because it has 4 right angles. Well, let's look at this parallelogram. How are we going to find the area of the parallelogram? It looks different. Okay, I know some of you may already know this, but I'm going to show you what we're going to do. Let's take a look at this parallelogram. If I folded this from the corner to the opposite side, and that made a right angle. If I folded that and then cut it, what I'm going to do is take it and paste it on the other side. What shape did I just make? Everybody? Did I change the area? Did I change the amount of space that it takes up? Did I add space? Did I take away space? No. It's still the same amount of space. So did the area change? When I went from here to here, did I change the area? No. Did not change the area. So if this is my base and this is my height, if this is my height in my rectangle, where is my height in my parallelogram? Right there. We can draw the height from one of the angles straight down to the base. But it has to form a right angle, because when your distance is on an angle, you're actually going to increase your distance. So here, if we looked at this side might be 5, but our height might only be 4, because the slants are going to be longer than your heights. So that's why we want to go with height. Because let's look at our triangle. If we wanted to find the area of a triangle, we do base times height. Would I just draw a line in the middle of my rectangle and change and add a number? No, I wouldn't just do that to my rectangle. So why would I do that to my parallelogram? So we're going to still use base times height. So back to our first picture. If this was our rectangle, 7 inches by 3 inches. Well, if I took my rectangle and cut it and made it into the parallelogram that I see down here, what did I do with my height? Here is my height. Now here is my height. So there is the height. So if this is area equals base times height, area equals 7 times 3, area equals 21 inches squared. So what am I going to do for my parallelogram? Area equals base times height, area equals 7 times 3, area equals 21 inches squared. So using our knowledge of rectangles, we can use that information to help us find the area of a parallelogram because they have the same area.
When I was studying for a state test and my mom showed me something from module 5, it showed that to find the height, it drew a line from the outside.
Well, hold on. We're going to get to that in a minute, all right? So one step at a time. So now I want you to try 1A, B, and C by yourself, but let's do number 1 together so I can show you exactly how I want it set up. Make sure the first row, you write the formula, area equals base times height. Then, as you know from our other modules, you replace the letters with numbers. Our base is 6. What is the height? What is the height there? Be careful. What is the height in picture A? 4 centimeters. So 6 times 4. Does everybody understand why we did not use 5?
What is 5?
5 is the measure of the side, of one of the sides. But that can't be used for our area. If we were going to find perimeter, then we would need the 5. It would be 6 plus 5 plus 6 plus 5. That's perimeter. We're not doing perimeter. We're doing area.
Okay.
Okay? Good question. Yes. To make sure you know which numbers you're supposed to use, to make sure you understand the concept of area and where it's coming from.
So is it just there
No, it's there to see if you know what you're doing.
I just don't get
Excuse me, it's also there in case you need to find perimeter.
I don't get
Why you would use the 5?
why you
Because we're using area. And area, I just need the base and the height. And that's my base because that's where my height is intersecting. Your height is going to go to your base. Your height always intersects or connects to your base. Okay? So 6 times 4, area equals 24 centimeters squared. So try B and C on your own, and then write your answers on your dry erase board and hold them up. All right, looks like everybody did very well. So we have 25 times 8. So that was 200 meters squared. 12 times 7, 84 feet squared. But now, hold on a second. Take a look at the board, please. Here's another picture. Here's another picture where if we drew the height from the angle to the other side, did it intersect with the base? No. What are we going to do? How are we going to find the height? So let's take a look. Can we use the same method that we used before? Let's take a look and see. Whoops. So take a look at this picture, and it was cut in 4 pieces that way. Then we cut off each angle like we did the first time. So far, so good?
Yes.
Exactly what we did. So then they took them and put them over here, put them over there to make rectangles. Then we took our rectangles and smushed them together to make a straight block. So here is our height. So let's bring our height back to our first I said bring the height. There we go. Bring the height back to our first picture. Can we draw the height outside? Yes. We can draw the height, whether we did it here, here, that represents the height. So you see in the picture down here, base, just that part is the base. That part is not the base. They just connected it out. But this dotted line is the height. So base is here, height is here. So now for 2, A, B, and C, the directions do tell you to use the ruler to measure. However, I don't know if it was in printing or whatnot, they don't line up to nice, easy numbers. We tried measuring them 6th period and it just got annoying. So, I'm actually going to give you the base and the height. So for A, draw the height from the one angle straight down so it hits the base to form a right angle. So there's the base. So the height was approximately 0.5. The base was 1.75. Before you solve it, I want to give you the measurements for B. B was 1.75 inches. The base was 1.25. Now hold on. Okay, good. I'm glad you just fixed that. Oh, you did the same thing she did. Boys and girls, you're not connecting. I just saw a whole bunch of people do this, so I want to point it out. A lot of people went from corner to corner. That's not how you draw the height. That's not correct, and I'm so happy that the two of you made that mistake so that I can point it out. It has to go straight down. Take a look at this. If it went over here, is it forming right angles? No. Now I've just got another angle. We said that the angles are going to be longer. So you want your height to go straight down and connect with your base on a right angle. And for the third one, you can extend your height out like that. Your base is 1 inch and your height is 1 inch. So right now, please solve 2A, B, and C. Write your answers on the smartboard and we'll go over them. On your dry erase boards, you know what I mean. All right, ladies and gentlemen, hold up your answers. Let's see. Missing labels on a lot of boards, I see. And be careful how you label your answers. For 2A, 0.875 inches, then the square. The number does not get squared. For 2B, area equals 2.1875 inches squared. And number 3, C, the most difficult, 1 inch square. 3, 2, 1.
Yeah, I got 1 inch, but if you were to measure like the bottom part,
Yep.
like
This is 1 inch.
so like the extension.
You don't,
Okay.
because that's not part of your shape. This, if you're measuring this, you're including that as part of your shape. That's not part of your shape. Let's take a look at the last one. This is something we saw over and over with volume. On a lot of the cumulative reviews, you can put everything away. Let's take a look at this. If the area is 35 over 42 centimeters squared, and the height is 1/7 centimeter, write an equation that relates the height, base, and area of the parallelogram. Then solve the equation. So we know we're always going to start by writing the formula. Then we're going to replace the letters with the numbers. So area, we're given the area this time. So we place the A with the fraction. We don't know the base. Well, we know the height is 1/7. So now I want to find the value of B. What is the value of the base? What would I have to do to solve that?
First you have to divide both sides by 1.
Exactly. We're going to use what we know about the identity property, and we're going to divide both sides by 1/7. Whatever I do to the one side, I have to do to the other side to keep it balanced. So that cancels out on the right, leaving me with B. What's my rule for dividing fractions? The first one I keep the same. I change the division to multiplication, and I take the reciprocal of the second fraction. Now, before I multiply my numerators and multiply my denominators, I know I have to multiply my numerators, I have to multiply my denominators, but before I do that, I can cross reduce here. 7 and 42 can both be divided by 7. So 7 divided by 7 is 1, 42 divided by 7 is 6. Now it's easier. 35 times 1 is 35. 6 times 1 is 6. But I know that I can't leave that as an improper fraction, so I have to change it to a mixed number. So 6 goes into 35 5 times with 5 left over, and my denominator stays the same, and my unit is centimeters. I'm looking at just the distance on the base, so it's just centimeters. I'm not squaring it because it's not the area. That's just the distance of the base. Okay? Yes. Okay.